So welcome to today's presentation on Schmidt Hammers. And I'd like to begin just with a little bit of a background on what I hope to cover during the presentation and what you should come away knowing afterwards. We'll discuss a little bit about the standards and procedures for compressive strength testing in Australia, just so we've got the context. So when I say MPa strength or concrete strength, we know what we're talking about. I'm then going to explain a little bit of the difference between the two Schmidt Hammer mechanisms available. So they're both used in the same way to evaluate relative or a correlated strength on concrete or other materials, but there's a physical difference in how they operate. So we'll talk about that. We'll talk about how we get compressive strength from the raw measurements of a Schmidt Hammer and what affects the raw measurement to a Schmidt Hammer. And I also want to quickly distinguish an early age strength measurement from an in situ strength measurement, which by early age, I mean while the concrete is curing, and an in situ measurement, I mean going to an existing structure where the concrete is already cured, or at least a 28-day strength, and assessing its strength on site non-destructively. I'm also hoping you'll be able to make an intelligent choice of equipment for in situ strength and know when non-destructive methods are appropriate and when it may be more appropriate to use destructive methods. Schmidt Hammers themselves are one of the oldest forms of concrete non-destructive testing. Excuse me a second, I'm just going to mute there. So they're invented by Ernst Schmidt in 1950, have been manufactured by Proceq since then. They're a non-destructive measurement of concrete strength, particularly related to surface hardness, and they're mechanical. So one thing to keep in mind is there's a good case to maintain the calibration and support of your Schmidt Hammers, and also to think about how long in service they have been. As a general guideline for calibration of the different types we supply, the original Schmidt design is typically calibrated once a year or every 1,000 impacts, and the SilverSchmidt design, with its better sealing and slightly different measurement mechanism, is able to be maintained without calibration for 5,000 impacts, or again, we'd like to do that yearly anyway. So let's just quickly explain what a Schmidt hammer is. It's a rebound hammer, and we correlate a rebound of a standard force on the concrete surface to a converted compressive strength. So a Schmidt hammer is not a small compression testing machine. It's not taking the same measurement as when we break a cylinder. Instead, we are using information from broken cylinders to create a relationship to Schmidt hammer tests that were conducted on the same cylinders, and that's where the MPa values come from. The traditional rebound hammer, the original Schmidt, which I've got a picture of here, was measured distance of rebound height. So if you look at the chart on that, we can see that that would be a reading of 82R off that scale, recorded by how far the weight inside the hammer rebounds. I'll actually show you a quick diagram of the internal of these hammers in a second, so you'll be able to see what I mean in more detail. But original Schmidt's design does use a height of rebound as its measurement. It's converted to compressive strength using a calibration curve. These are either supplied with the hammer by the manufacturer, so if there's a curve printed on the side of the hammer, or if you're using an internal conversion from units of R or Q, the rebound values, across to compressive strength, you're using a manufacturer curve. Whereas if you've worked with a laboratory to crush samples and build your own relationship, you've made a user or custom curve. And that is the preferred method. It's always best to have curves made for your particular materials and to understand where the manufacturer's curves come from if you are using them. Just so the first little bit of background I want to cover just really quickly is to go through Australian Standard 1012.8 and 1012.9. Between the two of these, they cover the casting of standard cylinder samples, their curing, their preparation before testing, and the crush testing to break them. That defines what we mean when we say compressive strength of concrete. The samples are taken from the concrete that's used on site, or they're prepared as part of a test batch, and are placed into a 2-to-1 cylinder with a cover and appropriately compacted. The standard defines dimensions and compaction procedures to correctly cast that cylinder, cured in initial curing in the mold between 18 and 36 hours, at which point it must be taken out of that mold and placed into a standard curing environment, either a water bath or a fog bath, a fog room. There's also sometimes specific requirements beyond the Australian standards, depending upon the client you're working with. So, for example, the Queensland Main Roads requires a wet storage of samples, curing similar to the element. It's also interesting to point out that we have different standard curing temperatures for that, depending upon where we are in Australia. If we're in Queensland, we're in a tropical zone. If we're in New South Wales, we're in a standard zone. The samples are then inspected. Because one surface in a cylinder mold, which is to be compressed against the platinums of the compression machine, is not smooth, it's not off mold, that's either ground plain with a cylinder grinding machine, or it has a sulfur cement cap applied or a rubber cap placed on top to ensure smooth contact, and then it's broken with a paste rate of 29 MPa. The standard also defines how that information will be recorded. And one important thing is typically these tests are done at 28 days, which means if we want to compare compressive strength values between two different batches, the tests do need to be prepared the same way and broken at the same time. That's the whole purpose of having the standards, is to ensure that because we're not directly measuring a material property, there is no strength, a compressive strength of concrete, so to speak, that is an absolute value that the concrete inherently has. It's an agreed upon test method where a certain amount of pressure breaks a sample at a certain time when it's been prepared in a certain way. So this is why it's very important when you're comparing strength results between two projects to understand that the tests are done the same way. And if you look at overseas research, or in particular things like Schmidt Hammer conversion curves, sometimes those tests are not done the same way overseas. We'll address that a little as we go, but I wanted to talk a bit just very quickly about how a compressive strength test is conducted. So moving to the Schmidt Hammer itself, it's at its essence a test of surface strength or hardness, and it's correlated out to strength. The original Schmidt curves will actually have a directionality to them too. There'll be vertical or horizontal testing, up or down, and it's establishing what's happening at the surface of that material, so it doesn't take into account the heart of your concrete. This is sometimes not an issue if you're looking to see strength gain. It may be lower on the outside compared to the inside. Now, it is also typically correct to test only on off-form surfaces or surfaces that have been ground back. A work surface at the top of an exposed slab is going to have a different rebound value to the off-form sections of the same material. So that can be a bit of a catch when you're trying to be very precise with Schmidt Hammer measurements. In standards internationally and as the manufacturers build them, there are two rebound energies which are used, a type N and a type L. Type L is a stronger impact than the type N is stronger than the type L. Type N is generally used for normal testing, and type L for thin concretes or very weak concretes. And also important nuance of the different types of hammer is when you go from concrete testing to something like rock testing, it's common to use a type L because the most commonly used standard there, the ASTM standard, actually expects a type L and doesn't make any mention of the type N. So that is something to consider, is there a reason to go with a default impact energy, or do you need a specific one? There's also more specifically designed hammers for very low strength. There's a pendulum hammer shown on the right there, which strikes with a lower impact energy and a broader impact face. Similarly, it's possible to modify a type L Schmidt hammer with what's called a mushroom head, which again is a broader impact face to lower the overall force of that impact. And based upon that, that can help you determine which particular Schmidt hammer range you'd like to work with. Of particular note is that the original Schmidt, in addition to being a little bit more scattered in its results, has a smaller measurement range over which it would typically be used. The SilverSchmidt is larger, and the pendulum hammer listed here as the OS 120 is most commonly used only for very low strength concrete or initial curing applications. Let me begin just in terms of mechanism. We'll start with the original Schmidt device. The original Schmidt hammer, we're measuring impact height. So we have to apply the type N force. And to do that, we have a spring, which is tensioned out, and a weight. So we know the spring, we know the force. And we can see from that, the spring will pull the weight down, which will rebound with a certain amount of force. And that rebound height is recorded. So we can see here that we actually measure out the distance that that rebound has occurred. And we're going to convert that. I've got a small question from Aria, who asked about recording the video. Look, if you have a way to do so, you could record the video. I'm actually recording it myself and will be posting this on YouTube when I'm complete. That'll be part of the email I send out at the conclusion of this presentation. So very welcome to do so, but there's no need if you'd like to see it again. It will be available. And you see then, again, as I showed at the start, we have the height of the cursor. Now, we've taken an impact, we've got a value of rebound, but we don't yet have anything that talks about strength. If we want to talk in units of MPa or PSI or some other measurement of pressure, we need a conversion curve. And it's important to understand not only what the conversion curves do, but also how they're created. So I've got 3 different conversion curves for an original Schmidt hammer here. The one on the left is a cylinder curve for 150 by 300 millimeter cylinders. So the same ratio we use in Australia. The middle conversion curve is a conversion curve made using 150 cubes, 150 millimeter cubes. So that second conversion curve, even if you put the exact concrete mix into those cubes and broke them, your MPa values would be higher when breaking cylinders than if you broke, higher than when breaking cubes than if you broke cylinders. You need, if you want to use a curve created using cube samples, to correct back to a cylinder sample curve. If you're using a digital hammer, the original Schmidt Live or the SilverSchmidt Live, you can tell it what your local sample type is, and it will correct automatically. But it's very important to be mindful if you're using a manufacturer curve or a curve from literature, what kind of samples it was created with. I've just heard someone's voice come through. Was someone looking to ask a question, or was they just muting, or are they just unmuted by mistake? Okay, I'll keep going, but do please feel free to ask questions in chat or video as we go along. A particular one I want to call out, the curve printed on the side of the Schmidt hammer, that's the green curve on the right-hand side, may be a cube curve. So if you have your new original Schmidt purely mechanical hammer and you use the curve on the side as your main measurement of strength, you may be overestimating your concrete strength. You need to be mindful of what that manufacturer conversion curve is. One other point with these curves is they're most commonly created using a standard Portland cement concrete. So if your concrete has a different construction, a geopolymer concrete, say, it may be inappropriate to use the manufacturer's curves. One of the other ones that comes up quite a bit is cement testing. If you're testing cement, the curves were built for concrete. If you want a cement curve, you will need to build that yourself or make use of one in literature. So I'll move on to a few more mechanisms now. Let's start by looking at the pendulum hammer mechanism. This is a really clear example of a rebound height measurement. You'll see the pendulum swing and you'll see it rebound to a certain position here and how that would be read off. So that would be a rebound of 130. And again, this would have a different conversion curve to the SilverSchmidt. So now the SilverSchmidt, this is a optical measurement tool. And we'll see that in a second. But again, we're just going through the different mechanisms. The blue SilverSchmidt is a previous model. If you have a SilverSchmidt Live, it is exactly the same internally on the mechanism as a SilverSchmidt PC or ST model. It's been mated with new data logging functionality that now goes to a phone or tablet. I'll show you the data logging when we finish going through our theory this afternoon. But so we'll look at a SilverSchmidt test now. It's used the same way as the original Schmidt. In particular, again, this is a previous control, but what we can see is how you test one area. So a single test is not a single impact, it's several impacts. So SilverSchmidt mechanism, hammer moves and rebounds off the mass, and we measure the speed of that. So to test one area, you take several impacts, usually at least 10, separated by a couple of centimeters. And again, then those are averaged and converted to MPa using a conversion curve. I'll cover how that's done with the SilverSchmidt Live in a moment, but this is the same kind of conversion. So why have we changed from an original Schmidt mechanism to a SilverSchmidt mechanism, from mechanical to optical measurement of rebound force? The difference is primarily one of precision and range. So it's not more accurate. A SilverSchmidt test is not necessarily a more accurate measurement of strength, but the results have less scatter to them, and it certainly is more appropriate to use a SilverSchmidt on higher strength materials. So the first big advantage is the speed measurement and the hammers themselves remove the influence of gravity. We no longer need to create 3 conversion curves to know if we're facing at an angle, up, down, or sideways. We can test at any angle. Gravity is no longer a concern. It's also got a larger testing range, as we saw in the comparison. Up the standard curves go up to 70 MPa, and it's possible, where appropriate, to build your custom curves to a higher value than that. The reason that works is there's 2 effects. One is the curves have a more shallow change between rebound value, so raw units of Q, and strength, so it's a little bit more precise inherently. The other part is, particularly when you're measuring, is that you're no longer measuring by eye. If you have a rebound hammer, which may be measured to 0.5 of an R value, an original Schmidt measurement, and you try and go from 70 to 75 MPa, your R value may go from 55 to 55.5. That's a very small change, and it's very hard to see on the side scale of the hammer. With a digital measurement, we can pick up that change more precisely, and with the inherent more shallow conversion curve, it's also more appropriate for greater strengths. So we have a question from Jimmy, which is, does result affected by amount of reinforcement, i.e. a heavily reinforced concrete or composite beam? That's a good question. It's a reasonable question. Typically, Schmidt hammer results should not be affected by the steel because it's a surface test. If you had steel with incredibly low cover right under the place of impact, that might have an effect. But because steel should be with 40, 50 mils or more cover, and we're impacting off the surface, that's not going to affect the measurement. Something that you do need to be mindful of, which might affect a Schmidt hammer measurement, would be the overall thickness and stability of the concrete. When you conduct a Schmidt hammer test, your concrete should return as much energy as it can to the hammer. So if you're testing something like a cylinder, and that cylinder is able to roll or move under the impact, the rebound will be weak, and you will underestimate strength or record a lower raw unit than is correct. So this is why we use Type L hammers for very thin concrete. The other big factor that can affect the quality of your test is the surface finish. So if you have a rough surface finish, even something as normal as a brushed surface finish, which is also a worked area of the concrete, which may have an inherent reduction, you need to smooth that down to bare, flat concrete. So I've got another question, which is, if the surface of beam or column has a finishing, paint or cement, do we need to clean it first, remove the finish before measurement? Absolutely. You do need to remove any surface coating, anything that gets between the hammer and the concrete. We are directly impacting the concrete with a steel plunger face and allowing that to give us energy back. If we have a coating there, that coating can crush down, take away that energy. It's no longer representative of the surface of the material. So your biggest concerns with Schmidt Hammer testing is smooth, clean, flat, uncoated, unmoving. One other factor is, now, because one impact is not definitive and there might be localized differences, aggregate close to the surface, maybe some amount of surface variation. This is why when we take a measurement, we don't take one impact, we take 10 impacts or more, and we average those results to further reduce the local impacts of tests. So first question, so does steel fiber have any effect on results? Say I have a dose rate of 30 kilograms per meter cubed. Now, I've not looked into literature or research on what effect a steel fiber would do to the overall test. Now, because that's not a normal concrete, it's not a sort of Portland cement concrete, it's not going to match up with the manufacturer's curves as well. So you would at least need some way to confirm Schmidt Hammer results are coming in similarly. But I can't tell you exactly what that would do to the test. It's a little bit too specific. You'd need to look into the question of steel fiber effects yourself, and ideally you should be doing this every time, building up a custom curve for the material you're testing. Merrick asked the question about carbonation effect, and that's correct. I'm actually going to talk about carbonation in a second. I'll explain that then if I may. If there's no more questions, I will move on from this slide. Is that okay? Okay, thank you very much. So we don't have a local standardization for the use of Schmidt Hammers in Australia as of yet. The CAA has been working on addressing the in situ strength measurements and is working towards at least some guidance by CAA in the Concrete Institute of Australia. But it's more common that people use Schmidt Hammers primarily according to the manufacturer's directions, or they may work according to an international standard. Some notable international standards I have listed here. The ASTM standard is American standard. Now, it defines primarily that Schmidt Hammers may be used for uniformity, to find regions of poor quality concrete, and to estimate in-place strength. So that'd be cured strength. It recommends a yearly verification, so that would be similar to our yearly calibration. And American standard is interesting. They're very well good at defining what a test is, what the hardware is, and what the test is, and a little bit about documenting it, but less how to use and interpret the results. Now, there's a couple of European standards that do relate. EN 12504-2 and 13791. 12504 defines the collection of the rebound values, R value or Q value. And it also has a more stringent verification requirement. So they want the hammer to be tested versus reference before and after the test procedure to ensure it's within calibration before the test occurs and remains in calibration after the testing at that site. That would normally be done with a calibration anvil. There's also a more compact verification anvil available with the original Schmidt Live and SilverSchmidt Live. This is a question that does sometimes come up on the SilverSchmidt Live or original Schmidt Live application. When it mentions verification, that's what they're referring to. Your calibration certificate is more a reference of, has the hammer been supplied reading correctly when supplied and when tested. Now, if we want to use the European standards for strength, they actually have annexes that define particular mixes. And also in those, they define how to shift those mixes based upon the real concrete. And they're quite stringent. You would need to take and break 9 destructive core samples to shift a standardized mix curve by the European standard, or take at least 18 cores from the structure to develop your own strength relationship. So bear that in mind. If you are doing your own strength relationships, it's not 1 or 2 cylinders, it's many cylinders for building that relationship curve. There's also 13791 that is a broader discussion of in situ compressive strength measurement and other forms of strength measurement, which addresses the whole picture of taking and crushing cores, using Schmidt hammers, using ultrasonic pulse velocity. Now, Marek, just coming, as Marek mentioned, carbonation is one other source of interference. Carbonation refers to the effect where carbon dioxide is absorbed into the concrete, forming calcium carbonate and water. This is of concern normally because the carbonic acid that forms is actually a risk of corrosion of the reinforcing steel as it reduces the pH of the concrete. But in the particular case of Schmidt hammers, it has an effect where while the compressive strength, the strength required to break that concrete does not change, the surface hardness does. Schmidt hammers assess surface hardness, so there will be a higher rebound value where you have carbonated concrete. So older structures, this is of concern, or structures with particular exposure to carbon dioxide, like road tunnels. If you would like to correct for that, the manufacturer's recommendation is to test the carbonated region, grind back below the depth of the carbonation that can be found with phenolphthalein pH indicator, smooth, so again, have to be smooth every time we do a Schmidt hammer test, and then get the conversion ratio between rebound values on carbonated concrete and then internal on the uncarbonated material from the same area. There is also a Chinese standard that looks at correcting by depth of carbonation. Now, I did have a question come through, which would you suggest that a custom rebound curve is required when assessing SCC versus standard concrete? So that's definitely the way you would like to do things, is to have curves made for your particular concrete, especially if the materials are particularly different to sort of the generic materials the manufacturers use. My guidance is, if you can, always have a custom curve. And if you can't have a custom curve, be aware that you don't know how good the match of the manufacturer's curve is to your materials. And sometimes that won't be good enough. Sometimes that uncertainty isn't appropriate. So there's other approaches you can take. You can consider, this is a good time to go on to the next point, looking at relative strength rather than an actual MPa strength. Because Schmidt hammers, the conversions are only so good. But one thing a Schmidt hammer is very good at, it is determining difference between the same material in different places. The example I always like to talk about is if you have finished one pour with a concrete mix and you've got all of your compressive test records and they're correct, and you then have a second pour and for some reason the samples are lost or incorrectly cast and they're not appropriate, so you don't have compressive strength records for the second pour of the same material, it can be very appropriate to gather raw Q or R values on the known good section and then determine if the second pour, where the results were lost, has similar values, comparing relative strength. So they should be very similar if it's the same mix under the same conditions. And if there's a difference there, then maybe it needs further assessment. You can also use this where, for example, you are taking some percentage of core samples, so collecting and breaking cores, where in regions where Schmidt hammer tests have been done, and then testing that same mix away from that core area. It sort of extends the validity of those cores, because a core, one of the big issues with a core sample is it's a single point in space. You know that that material's right or wrong, but you don't know if an area a meter away from it's right or wrong. A Schmidt hammer can give you that and is very good at giving you that. Now, if you are assessing the in situ strength of the concrete, either for the purpose of early age strength, so by that I mean curing strength from hydration to cured, or in situ strength, by which I mean an unknown strength of an existing structure, you need to have that conversion quality taken into account. So if you're using manufacturer curves, it's an estimate or guidance. If you've been collecting and building your own relationship, it's a better match to the real strength of the material. Some of the other work that is sometimes done is assessments of relative quality. So fire damage, where the fire may have physically affected the concrete, Schmidt Hammers are used for that. It's also common to match Schmidt Hammers with other materials. So Schmidt Hammer testing for rock is quite a common application, but with rock, it gets more involved because you need to have relationship curves for each particular rock material, just like you do with different mixes of concrete. Similarly, cement. There's also an application where Schmidt Hammers are used to test rolls of paper for the evenness of their winding. Essentially, that's a relative strength estimation. If it's evenly wound, evenly tensioned, there should be a comparable rebound value all the way along the side of that roll. So if we are working with the manufacturer's curves only, and it is already a reasonable match to the material on site, your accuracy will still be 20 to 25% uncertainty. We don't know exactly how that matches up, even if it was a reasonable material to use a manufacturer curve for. And manufacturers and standards absolutely encourage users to produce their own curve, as I'm doing today. You can do rudimentary connections to strength, shifting existing curves. So if you have a rebound value and it's and a crush sample, you can reduce or raise the entire curve relative, which is not ideal, but is one way to do a correction. Now, just to go with, if we are using manufacturer curves and what the default ones may be, this is for a SilverSchmidt Live in Australia. The key ones that you want is you need to be using a 2-to-1 cylinder factor on your scale, because that takes into account that we crush cylinders locally. Units of MPa, that's just appropriate units. It's also entirely appropriate to work without conversion, so to work in raw units of Q value. Now, the manufacturer supplies us with a number of curves. The two most commonly used is the lowest 10th percentile curve, so less than 10% on the chart here, and that is showing up as useful for in-place concrete, so existing structures where the concrete is cured and has been in use for some time. The European reference curve listed here is reference EU. This used to be called the traditional N curve on the SilverSchmidt PC models, is more commonly used for freshly cast concrete. So early age strength applications, it can be used as a rough guidance there. Because we're not testing to any international standard, we most often use mean as the setting for standard. Now, the conversion curve and the target scale for the SilverSchmidt Live or the original Schmidt Live are set on the application. I'll show you that when I open the application up shortly. But the conversion curve is physically set on the device. So it's going to be a little bit harder for me to show you that, but it's a setting we change on the hammer, is the standard. The other two are changed on the application and can actually be changed after the test. So if you've put the incorrect values in, you can correct the mistake afterwards because it's non-destructive. Again, most commonly, an original Schmidt curve used in Australia is a cylinder curve. So please be aware of that. And again, you would pick that in the original Schmidt Live application. So let's just talk quickly about how you make your own conversion curve. You need a series of sample tests before you can build a conversion curve. And typically, if you're taking cores, you would conduct Schmidt Hammer tests in the region of the core, then secure and break the core. If it's cylinder samples, the cylinders need to be properly supported to resist the energy of that Schmidt Hammer. So in a cradle of some sort, clamped into a machine, held firmly, so all of the rebound energy is returned by the core. It's not free to move under the impact. And again, then once the data is collected, a curve fit's established, and the formula shown here, which matches that relationship is recorded. This can then be input into the Schmidt Hammer application. So in this case, we've put the same information in. It's got a 30 to 60 Q range. So we actually tell the device that we only want the machine to return values of MPa if Q is above 29, below 60. So the raw value is above 29, below 60. It gives that relationship a value of between 15 MPa to 59 MPa that it can evaluate. So going from there, it is possible to use the same kind of correlation with other non-destructive tests. Quite a common one is to use ultrasonic pulse velocity. That is the transmission time of sound waves through the concrete from one side to the other. When we're using that, so we can measure from one side to the other, determine the speed of transmission. So that's velocity. So we, in the calculation, will typically measure the distance the sound has to travel and calculate velocity based upon that. Once we've done so, we can also take Schmidt Hammer results and use a correlation curve that, rather than being built with only rebound value or pulse velocity value, it's built with both. So it has an input of velocity and rebound. If you're using Proceq Pundit PL 200, there's actually the ability to load these curves in where it will measure, it's a pulse velocity machine, it'll measure the pulse velocity, and it will also take as an input the rebound value from the Schmidt Hammer. Finally, before I go into a few demonstrations and show you some of these things in action and answer any questions on the theory, I just want to talk a little bit about early aid strength testing. Early aid strength testing is a special case because it's about measuring the effect of the hydration. So that might commonly be used in precast yards to open molds to lift precast elements out of the molds. This is a very common application for Schmidt Hammers. It's also used in production sites for schedule and safety. So can we remove the formwork? Can we expose curing concrete to the outside air? Is it safe to allow traffic onto a new pavement? All of this is an early aid strength application. Schmidt Hammers are one of the options we have for assessing early aid strength. And the big advantage of a Schmidt Hammer test is you can do it again. One of the most commonly used is a early aid cylinder. So a cylinder is secured, and it's either cured in laboratory conditions, or it may be cured in the same curing environment as a precast element, or in some way to catch the real heat of curing, and then it's broken. And that's a good relationship to the in situ strength, particularly if the cylinder's tracking at the same temperature as the concrete itself. If it's at lab conditions, it's probably going to be coming in lower because it'll cure less quickly. But it's a destructive test. Once you break your early aid strength, you're done. You can't check again. If it breaks low, you don't know what to do beyond wait a sufficiently safe period. With a Schmidt Hammer test, or with other techniques such as concrete maturity, like I mentioned at the beginning of this presentation, you have a repeatable test. You know that your assessment takes into account the concrete on site rather than laboratory concrete, and also that it will be repeatable if you don't come to strength when you expect to. If you want to learn more about early aid strength, I will be presenting later this year on the topic again, and introducing the Insight system in some more detail. But I just wanted to quickly mention this application. It's a very common application for Schmidt Hammers. So before we continue on to just a few examples of using the hammer, does anyone have any more questions or comments on the theoretical presentation or anything else they'd like to address? Also, just going to quickly check that the questions that were asked, I've addressed them all. I think I have. It looks like I have answered the questions that were sent into the chat. If anyone would like to unmute and ask any further questions, please do. If not, I will start up my phone and show a few examples of a live test. Okay, so I'm going to just bring up my phone screen. which should be visible on the screen now. This is Proceq's SilverSchmidt Live, an original Schmidt Live application. And I'll be using SilverSchmidt Live as the sample. Turning that on, and I'll describe what I'm doing on the hammer, but you'll be able to see what I'm doing on the application. I'm immediately presented with a screen which says mean, which is the standard currently being used. That could also be an American or European or other international standard. Mean is not a standard, it's just an averaging method. It means there's no additional verification that we're using the hammer in a certain way. It's simply averaging several impacts. I also have in the bottom left corner 0, which means I am not in the middle of a measurement series, and I'm given the name for the next measurement series. On my application, if I click into hammer, I can physically connect by Bluetooth to the SilverSchmidt Live. And that indicates that connected. If I can even confirm that that's the same one that I'm holding here, it'll provide a light to show me that. And then I have on the top left square, measure has underneath it ongoing with an I. I'm going to go into the ongoing screen, and I'm going to rename my base file name to webinar, because that's what I'm collecting now. So we have this webinar file ready to measure. With the SilverSchmidt mechanism, or the original Schmidt mechanism with the live, Proceq Live, you start and stop your measurement series on the hammer. You adjust your settings on the application. So I can change my curve to lowest 10 percentile, which would be useful for in situ concrete. I can make sure my results are set to 2 to 1 cylinder. Again, useful for in situ for concrete in Australia. And then I can begin to take impacts. So I will line this up straight with the floor and press forward. I'm going to have to do this on carpet in the office, so we're going to have a very low MPa. Now, the orange color indicates that I don't currently have a large number of measurements. Once I've taken 3 measurements, it's now got enough that the average starts to be meaningful. If you had other standard, like European or ASTM standard verification going on, that wouldn't change from orange until it had met the requirements of that standard as well. So I've completed 10 measurements on my hammer, and I can now, with the buttons, tell it I would like to finish my test. And now my screen of my phone goes to indicate webinar 2 at the top rather than webinar 1. That measurement's complete. And I could take another series and complete that when I'm ready as well. So now I've taken 2 measurements under webinar. I can come back out on the phone. And if I go into the measures at the top of that top left box, I can see both of the measurements I've got, and the green cloud means those have been uploaded to a cloud service. Under each measurement, so back to webinar 1, the first 10 impacts I took, we have an average Q value of 33.4 Q, converted to an MPa of 11.3. I was testing over carpet, so I know that's not a real MPa value because I wasn't testing on bare concrete. I also have statistical information, so my minimum and maximum values in Q and MPa, the range between them in Q and MPa, and also the standard deviation between each of those. If I move my cursor, I can also see a chart of each test and the range of the strength scale, and I can see the results of each measurement. Because I have this set up on Proceq's cloud service, I can also bring up the same results in Proceq Cloud. So I'm going to change across to a browser window now. So you can see on the browser, I'm connected to my SilverSchmidt Live, and we can see under data review that I have my webinar 1 and 2 measurements here. So let's go and look at one of those. I have my individual measurements recorded. I have also got a logbook, which shows me I took this measurement in the office out at French's Forest here. It shows any changes I've made, what kind of Schmidt hammer I'm operating. So that's all coming together. I can also, on my phone, actually record where that measurement was taken. So there's the office floor that measurement was recorded on, and that will also now upload to the cloud. I have a question from Josh. Does the cloud service come with an additional cost or an ongoing subscription? The SilverSchmidt or original Schmidt hammer does not require any additional cost or subscription. The purchase is outright. You receive the cloud service with the hammer at no additional cost or ongoing subscription. So now I have, so I'll now have stored, as well as everything else, that image will update as well. A final step is I will just show on the application what the interface for making a custom material looks like. I've got a couple of examples here. They're not real conversion curves, but you see that the operator can choose forms of relationship and put the parameters in. So you need to do a little bit of work in Excel or with other statistical program to determine the relationship curve and then enter into this value. This does mean that once you've got a custom curve built, you'll be able to work with that directly on the hammer. Is there anything anyone else would like to see while I've got the demonstration equipment, or any questions on theory or practice? If there's not, I will finish up the webinar. Yes, the software, you do have a record of on the software and on the hammer of the number of blows performed. You have, so if we have a look under the application, under the hammer, we can actually see our measurement counter. So this hammer has performed 1,892 impacts. Jeff, you'd be very welcome to come into your local office for us to take you through how to use the hammer. We've always got time to do that at PCTE. So if you're in New South Wales, Victoria, Queensland, or Perth, very, very happy for you to come in. If you're elsewhere, do keep in touch. We'll try and catch up with you where appropriate. Thank you for the question, Dennis. The question was, does the custom curve have to be developed for each test series we are going? I don't quite follow. By test series, do you mean a particular mix or a particular series of compressive strength tests? If you'd like to unmute, we can also answer the question or over the thing. The question from Josh was, if you change any settings at the start of the demonstration, will this filter through to the data saved from the cloud? It does. So if I decide that I don't want these data to be converted using a 10 percentile, I'd rather use the traditional N curve or a custom curve, I could change that on the phone application, and that would update on the web service. The web service also, and the device itself, can also export data in PDF or CSV for you to do more work with. So if I want to go into my webinar data, I can export that as a PDF or as a CSV. I can also, if I would prefer, send that data to another user of the original Schmidt or SilverSchmidt application, the same measurement. So if you create an account for Bob and Susie does some testing on site, Susie could send the whole test series to Bob to load into their instance of the application. So a question from Dennis, with the new Schmidt hammer, what is the pricing and is the web service included? Dennis, I'll get in touch with pricing or ask your local manager to send you pricing. From Jimmy, does this model have Bluetooth connectivity, Proceq SilverSchmidt Type N? So Proceq SilverSchmidt Type N is not necessarily the product code. The Proceq SilverSchmidt Live would be the most recent one. That's the unit with Bluetooth connectivity. If you have a Proceq SilverSchmidt PC or ST, they're the blue hammers rather than the more recent black hammers. They are an older unit that does have data logging on the PC models, but connects across to a computer rather by a cable, rather than the black hammers, which connect by Bluetooth to a phone. So is it the same cloud storage used for other PCTE tools such as Impact Echo, or will the data be spread across multiple platforms? The clouds tool, Proceq Live, is to the manufacturer Proceq or Screening Eagle. So in that particular case, all your Screening Eagle or Proceq instruments will go to their cloud service. And then there will be other and then if there another unit offered cloud server storage, that would be separate. Of the Impact Echo equipment we do supply, we don't have one that offers cloud storage. Sorry, I've got a few more questions coming through. Give me 1 second. Thank you, Dennis. I'm glad I was able to help out. Andrew Breckenridge asked, will you be running a similar webinar for, say, the ultrasonic pulse velocity? I'd be very happy to. I actually intend to next present a webinar on cover meters and their use, but we do like to do at least one webinar every year on sonic tests, which would include ultrasonic pulse velocity, ultrasonic pulse echo tools, impact echo tools, several different techniques. The reason I combine sonic testing in presentations is that there's a very good case to combine several sonic tools when assessing structures for voiding or damage or delamination. It's important to sort of know the broad area of testing a technique covers, rather than using a particular named technique. So Schmidt Hammers are one tool to assess in situ strength. UPV would be another tool to assess in situ strength. And then you have techniques like concrete maturity based upon temperature measurement, which does in a different way for different purposes. So this has been purely about Schmidt Hammers, but what it really has been a discussion of concrete compressive strength and also relative strength measurement using a Schmidt hammer. Again, I'm going to keep an eye out for a few more questions for a few more minutes, then I'll sign off. So please feel free to respond in the chat, or this is another good chance to unmute and say hi, go through anything you'd like to cover. Thank you. I appreciate everyone who came along today, and I hope this has been a good broad overview of the theory and techniques and the use of the Schmidt hammers. Again, I'm just going to double check I haven't missed any questions. Thank you, everyone. It's a pleasure to have people attend. Of course, Darren, I will get you some pricing. I'll just make a note. I'll make a note before I sign off that you would like pricing. Of course, I'll be sending emails out for upcoming presentations as I do plan them, like we've done here before. Thank you, everyone. I appreciate the note of support. All right. I'll close things up now. My intent is to post this presentation as a video shortly, so keep an eye out for that. That'll be on YouTube. We will also send out a wrap-up email with a link to the YouTube presentation for those who could attend and those who couldn't, and an opportunity to request any more information you need on the new Schmidt Hammer products. Thank you so much.